Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am Dean Phillips, and I am your host today. I have the distinct pleasure of having with me Ralph Resnick, who is the founding director of America Makes, now recently retired, but still involved with his company C3 Consulting. Welcome, Ralph.
Well, thank you, Dean. It's so good to be with you.
It's good to be with you and good to catch up. It's been a while. Ralph and I have served together in the SME on the board, and it's been a few years, but it's good to catch back up with you here.
Same here, Dean. It's as you know, I am passionate about manufacturing, and so I'm looking forward to talking to you about what the future holds.
Great. So right off the bat, what does the future hold? What do you think is going to be changing over the next 5 years, and how are we going to improve as a manufacturing country? Well,
as you know, manufacturing is critical to the nation, and I'm glad to see that there is a revival and an appreciation for the significance of manufacturing. I really think that the pandemic opened our eyes and made us aware of the significance of our supply chains. And with the way that manufacturing has gotten distributed beyond the walls of the factory, beyond even the borders of our country, we see the fragility of that supply chain and how significant it is to have a strong manufacturing base that can support our efforts. With that being said, I think we saw how technology can help with those supply chains, both in making sure that we have secure communications and transfer of data. The need to monitor our processes and to assure that they're producing good product, and making sure that our supply chains are strong and utilizing the advanced technology. What that also means is that we need to have a workforce that's trained and has the skills to be able to execute properly and to assure quality of products. So that also has gotten a lot of attention, and we see a lot of efforts with many organizations that are trying to take care of that issue. And I know that you're deeply involved with that, Dean, and I applaud you for that. So I think that, within the short-term future, we're going to be seeing more engagement of software tools so that we can be truly realizing the power of the Internet of Things and manufacturing and Industry 4.0, being able to do a digital model of the manufacturing processes, a digital twin of the products, and bringing that all together in a closed loop fashion is going to impact manufacturing. It's going to impact our workforce. It's going to impact the quality of life that we have in this country and around the world.
Excellent. Do you think that things like blockchain is going to help us with some of the areas like securing data and also monitoring the processes and try and shore up some of those difficulties we've had with supply chain?
Yeah, I think that that we're seeing improvements, and unfortunately, there's some hiccups. We're seeing what's happened with crypto and so on.
Mm-hmm.
So I think we have to be careful with how we handle data. Security is important not only for things like DoD, but also for our individual intellectual property that small businesses feel comfortable of participating in the digital economy.
Right. So tell me a little bit. Let's circle back to your background. How did you get involved in manufacturing? What got you interested?
Well, whenever I was going to college, and also I had attended some trade school. My first job was with Westinghouse Transportation, and I was going to school and working at the same time. I quickly realized that the projects that I was working on at Westinghouse were much more advanced than the training I was receiving. Mm-hmm. So I focused all my attention on working on these exciting rapid transit projects, and then my passion for making things just expanded, and I was lucky to run into a gentleman by the name of Larry Rhodes. And Dean, I don't know if you've ever met Larry, but many people that are in manufacturing recalled Larry's passion for manufacturing and his insatiable appetite for new technology. And so I was privileged to eventually become the CTO of Extrude Hone, where Larry started a company based upon silly putty and grit. Being able to polish internals and critical features on things like turbine engines. That also then expanded into going to MIT and discovering Professor Ellie Sachs and 3D printing. And as the CTO, I visited the MIT labs and came back to Larry and said, we got to get involved with this. And we did. We were one of the first licensees of the binder jet printing from MIT, and then expanded that and commercialized that and turned it into ExOne, where they now have recently been purchased by Desktop Metal. And throughout that, so that was from the early and mid 90s, I've been involved with additive and haven't looked back.
It is an exciting field for sure. I think that it's limited by your creativity of what you think it can do. It's amazing.
I agree. I mean, early on, we tried to focus on the exploiting the benefits of 3D printing. And unfortunately, I think we saw a drop in enthusiasm early on whenever the technology might have been oversold and people got burnt. But I think now, people are starting to realize, especially with the advent of advanced software tools, design methodologies, that if we look at the the killer applications that additive can bring. It, like you said, it can be revolutionary in how we go forward. So design for additive is very important, and I also think having models and physics representations of the processes are necessary to really take it to the next step.
Right. What about the material science aspect of it? It seems like that area has really kind of allowed us the ability to get to some of the places. I think back to your point of maybe things being oversold, I think some people were like, we'll be able to print all of these different things. Well, we needed to get the materials to get us to some of these opportunities. What have you seen, and what do you think about some of those?
Well, I think that, additive is significantly different than some of the other manufacturing processes and in the transitioning process. Because when you're doing, for instance, in subtractive machining, whether that be milling or turning or even EDM, you're working with the material that you know what the properties are, and there's a lot of physics and data behind that, right? Mm-hmm. Whereas in additive, we're not only transforming the geometry, but we're also transforming the material itself, whether we heat it up, melt it, and then lay it out, whether we spread powder and use a heat source to consolidate the part. So there's a lot more going on with 3D printing and additive manufacturing than there is with some other transformative processes.
Right.
So on one hand, it's a very positive thing, right? I mean, we can custom engineer the material, in some cases down to the molecular level. And so there's great promise on what can be done there. Not only a monolithic material, but being able to have graded structures and be able to transition based upon application. But the other thing is the physics that are behind that transformation, and how we can control that and assure that we're going to guarantee repeatable results, time in and time out, on the same machine, on multiple machines, on multiple locations. So that's a tall order, but there are many that are researching this and developing this throughout the world. So huge opportunities, many issues with regards to that, but being able to customize the material in a way that we have never been able to do before is very promising.
I've seen quite a few companies now getting into blended materials where you're taking you're adding things like wood to an already existing material. So you're taking maybe a plastic and you're blending it with wood pulp and creating a new material where you can do that. And especially in like the metals, being able to blend in different aspects of it. It takes on a whole different thing. Like you had mentioned, it takes on a lot more chemistry even when we start getting into the material side of it. What are some of the challenges that you've seen when you start kind of playing with the chemistry side of it when you're already trying to balance speed, how fast you're doing it. You're trying to blend the temperature to be consistent when you're manufacturing certain things like PLA and stuff like that. What are some of the challenges that you see in some of these blended materials?
So I think that early on, additive manufacturing was its own worst enemy. We had a lot of intellectual property that was around some of the original additive processes. That meant that organizations were not only providing the equipment, but also providing the materials. So you had this unhealthy parochialism that was going on. Mm-hmm. And we didn't have the material organizations that had the expertise engaged with the additive community. Additionally, the additive community wasn't that familiar with manufacturing in general and rigors of being in a production environment. With the advent of the patents running out and more people realizing the potential of additive, we began to see involvement of premier material companies. And so, they started developing advanced polymers and advanced alloy systems for metals. And we started getting the material universities involved in doing the appropriate research to do things like field materials and different alloys, and adjusting the process parameters to be able to make this happen. I think, we're going to continue to see that, where we're going to have, you mentioned chemistry, and biology, and so not only the materials, but also the geometric freedom that we have in design and manufacturing, so that we can do things like internal passages that you just can't do any other way, or being able to do intricate lattice structures to really exploit biomimicry and be able to have these natural shapes and optimal shapes that are refined through advanced software tools like topology optimization, and doing regenerative engineering. Because now we have a way of taking that virtual world and turning it into something real and useful. So, doing things like using some of the material modeling tools, it's being able to bring all of those disciplines together and have them contribute appropriately is having a huge impact on the industry.
Gotcha. Yeah, and I think that, as you mentioned, I didn't mention it earlier, but you're absolutely right. Biology is an area that we're looking at now, and there's more and more opportunities for us to be better at things. So it was kind of cute and interesting when you could print pancakes and you can print Hershey's chocolate and things like that. But I think when you start getting into printing cells or taking cells and actually using them to print into other aspects of the human condition. What kinds of things do you think this is going to open the door for?
Oh, it's immense. One of the benefits of additive is that every part you make can be different. I equate it to printing snowflakes. Every snowflake is different. Mm-hmm. That means that mass customization, and where else could we use mass customization but in the human body? Because all of us are different.
Right.
So being able to custom make an implant or custom make a liver is, per the requirements of that individual, are earth-shattering. We're seeing the embrace of this in the medical community, and being able to, like I said, do this per the application and meet those custom requirements is we're seeing that grow, not only in things like implants, but we're seeing it in dental and virtually all aspects of the human body. And then also being able to take biological materials that are possibly carbon neutral or much more friendly to the environment, and being able to reuse materials and so on are that's approaching mainstream. Right.
And it's interesting you mentioned that, because that is really the wheelhouse of additive, is the customization. It isn't in the volumetric amounts of, hey, I can reprint the exact same thing over and over again. The thing that gets people interested in additive most of the time is that customization aspect, that I can tweak this, I can tweak that without really impacting what I'm trying to do holistically.
Exactly.
Yeah.
You're able to do quantities of one,
mm-hmm.
right? And you're able to do multiple part families and all of these things that were difficult before. So yeah, and it's cool. So kids are interested, and inquisitive engineers are interested. So yeah, it's good stuff all the way around. But again, we need to have people trained to really maximize the use of additive and to appreciate the design freedoms that we have with it.
Right. And I think you hit on one of the aspects there that of how do we get kids interested? How do we get the next generation interested? And one of them is it cool? Is it something that they're interested in doing and can see as a career? And I think that's one of the aspects that additive has over a lot of the other areas is, wow, that's pretty cool. I'm making a difference. And those aspects are some things that younger generations are looking to really make a difference, and they're looking at how can they do this, and getting involved in additive is one of those ways. What other?
Well,
I'm sorry. Go ahead.
Yeah, another thing is, I'm constantly amazed at the ability of our kids to appreciate the 3D aspect of things like additive. And that's because they have grown up in a 3D world,
Right.
and a 3D virtual world, right? I mean, with their gaming and so on, and parents are always, can't have Junior in front of that game all the time. It's not doing him any good. Well, he's and she are developing that capability of seeing things in 3D that we didn't have. We were, 2D drawings, right?
Right.
And being able to see solid models and to produce solid models and to have that 3D perception is huge. And they know that world. And when they see that, not only can they be in the virtual world, but they can translate that into solid objects and make something, just strengthens that excitement and that zeal and passion to take it forward. So parents, don't chase your kids away from screen all the time.
No, that's a very good point. Is when I was taking drafting classes in the 80s, it was you were taking a 3D object and figuring out ways to draw it in 2D. But now kids are thinking in 3D. They are thinking in that mode of that, which allows them to be more creative in the 3D world because they've never not known that. And I think that's a very good point you make there, because kids have had that opportunity. We were playing Pong.
Yeah, that's still 2D, right?
That's right. So we never had the opportunity to move in the environment, which most of the games now are that. They are moving in an environment, which is, even though unless you're wearing a headset and you're getting some 3D motion within it, it's somewhat 2D, but you're moving in it, and it creates a 3D vision and experience.
Yes. Yep.
What other challenges do you think that we can overcome here in the near future for workforce?
Well, I think that number one thing is, I personally think our educational system is broke. And that's because it has not kept up with the technology, because the technology is just too fast moving. I talk to my academic friends, and for instance, our friend Tom Kerfus at Georgia Tech, that was on the board with us and has contributed so much to SME. I say, Tom, how do you guys stay smarter than your students? I mean, how do you keep up with all of the technology advances that are occurring? These kids are coming into college already being capable of designing in CAD and knowing how to use CFD and some of the modeling packages. And so they're coming in at a pretty high level. So all the professors have to try and stay smarter than they are,
right,
or more advanced than they are. And that's an ongoing challenge. And, also and we're seeing a relaxation of the formal requirements of education. So, thankfully, vocational training and skills training are being looked at more favorably than they were in the past. And so there's not a stigma attached to that kind of manufacturing training. And thankfully, because there are skill sets there, practical skill sets that that need to be exploited and need to be further refined, so that we're not missing that valuable aspect of our workforce.
That's a great point, because I think it seems to me, anyways, when I went to a vocational high school before I went on to college, and those skills that I learned in high school are probably more valuable than the things I learned in college, because they were very specific when you got into college, whereas in high school it was very a little bit more general, but it was skill based. And I look back on it as they didn't tie you to a path either, as much as it seems like now everybody has to fit in the same box.
Right.
I think that's been the challenge.
Well, and as we talked earlier, to really realize the benefit of these new technologies, it includes involving individuals from a variety of disciplines, from the virtual, from the physical, from the chemical, from the biological, all of these organizations working collectively, and these individuals working collectively towards moving this all along.
And I think that's what we want, right? At the end of the day, we want to have more collaborative environments, and we've been challenged, I think, in some ways now with COVID and with the work from the remote working workforce that we have now, and I see a lot of people getting into self-training. Like if I'm designing something for VR or things like that, kids today are learning the engines for behind those, like Unreal and things like that. And that's given them, as you mentioned, that's a foot up right away walking in the door. And now college professors are being forced to, okay, can you do everything that they do?
Right.
And it's,
about 10 years ago when I was at NCDMM, I went to a local vocational school during the summer. Mm-hmm. And they had a summer program going on where they had about a dozen students, middle all the way up through high school, that where they came and designed like a Pinewood Derby car. And they used, so the kids learned CAD. They used CFD to be able to see what the aerodynamics of their cars, their designs were. And they then milled the frame out of aluminum. And so they learned to program a CNC machine. And then they used a 3D printer to print the body. And then they then raced them to see how their products performed. When I was just flabbergasted at these kids in what they were accomplishing. And then the guy said, well, there's this one girl here that is helping us. She's a little bit more senior. And he said she saw that we had an EDM machine. And she wanted to program the EDM machine. So the instructor gave her the manual and said, I don't know how to do it. Here, go ahead. She wound up learning how to program the EDM machine and make some parts. And so I asked him, this was like a 2-week course. And I asked him, I said, well, are you going to do this again next year? This is fantastic. And he said, well, we don't have the funding to support it. It cost about $5,000 for us to run this program. I said, for each student? And he said, no, just for the whole program. I Oh my God! Why are we not supporting? Such a great effort here, and so I think that we're seeing much better things happen now than we did 10 years ago, and I would hope that that the powers to be would see a program like that and say, this is a slam dunk. Of course, we're going to fund this.
Yeah.
And I know that you're involved with Tooling U and the efforts through SME and the Educational Foundation, Prime, all these great efforts that are going on there. And I think those are having an impact. And we need to continue to support them.
Yeah, I couldn't agree more. And even in the local SME chapter here, we've for quite a while now, we've had where we give out scholarships, but we've now even started to look at what else can we do with these schools, and programs exactly like what you're talking about are things that we have worked with local schools and doing things like the VEX robotics program and some of the other FIRST robotics, et cetera, that we've helped to try and fund, because that's what's going to make a difference in getting these kids interested in what they do. And when we did one on Manufacturing Day, to see those kids, anybody who thinks that kids, they're not what they used to be and blah, blah, blah. I'm telling you, you come out to one of these robotics competitions and you will be amazed, and you will have no doubt in your mind that these kids are going to far surpass us in what they can do in technology.
Well, one area that I'm concerned about, and you don't see a lot of press on, is some of these programs are really good, but they only help out those affluent school districts. Something like FIRST Robotics, that costs a lot of money to be involved with that. Right. And those school districts that can afford to support those teams, that's great. But I'm also worried about, and I think we're missing the boat on both inner city and rural schools. I live in a rural area, and I see that the kids don't have some of the opportunities that some of these more affluent school districts have. So I think we need to find a way to assist both the rural and the inner city schools. There's a lot of talent there that we're letting slip through the cracks. So I'm putting a plug in for my rural and inner.
I agree, and we've tried to do that. When we had our Manufacturing Day event here in Nashville, we reached out to a lot of the local schools to have them come over and participate, and we were even working with them to try and find funding for their programs. And it is a challenge, and we have a lot of rural here in Tennessee too. And yeah, you're right. A lot of these small schools in small towns, it is very difficult for them to compete in a program where you've got a more affluent area, but also just concentration of students. Some of these small towns, you might only have, in some of the small areas, it may have one school for the whole area, and that
right.
That also can be pretty difficult for them to catch up in some of those technology areas.
Yeah.
Well, Ralph, hey, sir, we are just about out of time. It has been great to have you here today, and I look forward to hopefully seeing you sometime in the near future. Tell people how they can get in touch with you.
So sure. People can email me at Ralph Resnick 1952 at iCloud.com. And I also I'm on LinkedIn and follow things closely there. So I'd be glad to talk to people, and you will not see on my profile open for work. So
it's okay. You know, we know that you still contribute in many, 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 many ways, sir.
Well, I continue to be passionate about manufacturing like you are, and my many other friends and associates out there. So, as we said at America Makes, when America makes, America works.
Excellent.
So, thank you, Dean, so much. It was great talking to you again. Thank you for reaching out.
Thank you. Everybody have a great day.
You too. We'll see you now.